Welcome to the Kanban Coaching Exchange, the first one of 2026. So I'm very excited to see all of your happy little faces again, and to be back in that learning mode. I think I've slacked off enough in January, and now it's time to get back into that improvement feat. So I'd like to welcome our first guest speaker of 2026, and that is Nick Brown. I first met Nick many years ago when he was actually working quite closely with a colleague of mine, Basil Arden. They were doing lots of conversations around data and tooling, and that's actually what I then became to know Nick from. He was kind of like a data guy interested in the story of how things change, but also Nick is very experienced in any agile method, leadership, growing teams, organizational transformation. So I'm probably selling him short when I say he's that data guy. But Nick then later joined an old haunt of mine, ASOS. So he worked at ASOS for many years. So he went through the trials and tribulations of implementing something the size of the Titanic. And from reading his latest book, which I'm sure he'll have a page on, which is definitely worthwhile reading, it talks about, how you can use the most appropriate things to be able to help to understand how your teams are doing. So if you haven't got that book, I will pop it into the chat channel so you can have a little look at it. But it's definitely worthwhile having a read, and you might also find some sort of paragraph from moi in there as well if you read hard enough. So without further ado, I'm going to hand over to Nick, who's going to tell us all about CFDs and using them and the pros and the cons and all of the good stuff that he's here to tell us about tonight. So over to you, Nick. Take it away.
Thank you. That's probably the best intro I think I've ever had as well.
I
So
know,
there
I'm
we
pretty
go.
awesome at this.
Oh, you clearly done your research.
Just
And it's
don't let me down,
testimony
Nick.
to Helen that all the years later at ASOS, so many people still talk about her
Ah,
in a good
beautiful,
way,
beautiful.
not just talk about her.
I like to form some sort of cult, a cult following.
Yeah, the cult of Meek. That's all right with me. So anyway, so tonight, thank you all for giving me some time of your evening and tuning into this session. So I will talk about burn-up charts and effectively how to move away from them, but also kind of some of the things that I see in the industry, particularly on things on LinkedIn, people that advocate things like Monte Carlo, let's say, and also some of the pitfalls with that. So trying to understand what is the right technique to use depending on the particular context. So we start our journey, like all things agility related, looking at Agile Manifesto. So some people might argue that Agile is more about kind of like teamwork and maybe running fluffy retrospectives, but it's always been about delivery. It's in the very first principle of the manifesto, and that we're focusing on delivery. And obviously, when we're looking at delivery, we need to track progress and if we are on track or not with regards to what it is we are trying to deliver. And for many years, the burn down chart, which you're seeing on your screen, was a tool that a lot of teams use. So on the left-hand side, on your y-axis, you have scope, the amount of things, be it points, items, hours, and it would reduce over time depending on how much work was completed. And when I was kind of putting this together, I like to credit original sources. So we can blame Ken Schwaber for burn downs because apparently he's the one that created them. I'm just kidding. We don't have to blame him, of course. But if you go on the Wayback Machine for Ken's website, this is what I think is the first kind of documented explanation of the burn down chart. And the slides I'm sure we'll send out afterwards. So if you want to look at the link, you can do. But this was kind of the first mention of it in terms of how it works. In this particular context, Ken's talking about using it in an hours perspective, so the hours of work remaining, reducing over time, and the decrease of the line being the velocity of work that was completed. So if you want to read about the origins, you can do. And obviously, a burn down is great because when scope changes, we can see that. So when the line goes back up, we can see that scope has been added. This may be teams identified additional work, rework was needed, new requirements have come in. It doesn't tell us the answer, but it does getting us asking better questions. The challenge is that because we are including completed work in the same kind of calculation, it can mislead. So sometimes your remaining work line may look like this, where it goes kind of down a little bit or it has a steep decline. And the problem is it doesn't give us any indication in terms of, well, is that the team suddenly completed a load of work, or is it scope's been reduced? So it's not particularly clear in terms of, well, has scope changed, or have we just completed more work as a team? So what followed was the creation of a different chart called a burn-up chart. Now, it's very hard to find who actually created this. I couldn't find a real reliable source. Certainly not as reliable for the burn down chart anyway. But this visualization is slightly different. So we still have our time on our bottom axes, our x-axes, but on the left-hand side, we've got scope. So we can see where these two lines intersect, which is basically plotting when we're going to finish the amount of work that is remaining, i.e. the scope. And what's great now is that we can see when scope changes and the rate at which we're completing work. So we can very easily now visualize when scope has changed and also plot our trajectory for completion. And if you Google burnup chart, you'll see lots of different instances. This was from a search a few weeks ago. And I was looking at this and I thought, hey, that's me. I was using that. And to give you a real example, because I always like to use real examples when I'm talking about things I've done, this is more than 10 years old now, which is kind of an indication as to some of the trials and tribulations I've been through in my career. So at the time, I was, dare I say, a project manager, or at least that was the title I was using. And I was leading a project for an organization called Royal Mail in UK, probably biggest logistics organization. So when you post a letter or post a parcel, it typically would go via them or through their network. Other logistics companies are available, of course. And at the time, we were doing a project where we were introducing a 2D barcode to all our parcels. So that's the barcode you can see on the right hand side there. It looks like kind of like a QR code. At the time, they were just using 1D barcodes, which is the one to the right, which you typically see in a supermarket. 2D barcodes, if you're struggling to sleep at night, they're more data rich and they prevent fraud in terms of people printing fraudulent online postage that they use to send parcels and letters. So it's a big driver for the organization to basically have this 2D barcode on all the parcels. Anyway, so we were working on this project where we were adding this to the online postage journey. And we were forecasting when it was we were going to complete. So we had our scope in terms of the total sum of story points, that kind of dark blue line you see there at the top. Our forecasted pace we were going to be delivering at, and then the blue line being the actual. And then I would get in front of steering committees and program boards and saying, yeah, we're going to go live on the 5th of June based on our forecast and the rate at which we're going. Now, in kind of more modern environments, tooling like Azure DevOps and Jira, they've enabled us to very quickly generate these charts so they can just quickly hook into backlogs and visualize that information. So you can look at things in terms of a burn up chart, looking at the scope, how much we've completed, the average rate at which we're completing stuff, when are we going to complete. So in this particular example, which is from Microsoft's own documentation, the 13th of October, 2017. And here's a couple instances of how you can do it in Jira. So you can do a burn up chart on the left hand side. That's more at a sprint level. And on the right hand side is what's called the epic report. And this would give you a range in terms of your predicted optimistic and pessimistic dates. So it tends to be the right hand side that people use more because it's looking further out rather than just a sprint. It's like maybe delivering an epic or multiple epics or a larger piece of work. Now, the problem with these charts is they use what's known as deterministic thinking. So they're assuming that there is only one outcome that can occur, that one outcome being the date at which we're going to complete. So in the Azure DevOps example, for anyone that's out there using that, we've got our projected completion date. So we have our weekly amount of completed items. So you can see there I've annotated it with how much it has gone up each week. And then what happens is it looks at the average over a specific number, so not all of,
Right.
but a specific number of weeks, and it calculates that average burn up, and that's how it comes to the conclusion in terms of when your project is likely to complete. So what we can do is we can say, okay, well, if we look at different amounts of data we use, we can look at what our average burn up is. So in the visual shown, it was using, I think, 7 weeks worth of data. But actually, if we start using different data sets in terms of the last 6 weeks, 5, 4, 3, 2, 1, well, just two, sorry, we see the average burn up changes. And actually, when you compare that with what the tool is using to forecast the date, it might present a different picture. And the key question, of course, is, well, okay, based on this, will we actually make our forecasted date? And I would say, based on that information, it's fairly unlikely, certainly for the last 2, 3, 4 weeks worth of data, if we're using that. If we start using 5 weeks data, maybe. And if we start using 6 weeks data, probably. And I'll explain to you shortly as to how I can come to that conclusion with data. But if we're forecasting and we're using that information, and it's highly unlikely, the date we're presenting, it's probably not the best thing to be doing from a delivery perspective. Now, if we look at JIRA and we do a similar exercise, we're going to focus on the EPIC report here. There's three potential outcomes that could occur. There's a predicted, an optimistic, and a pessimistic date. So this is slightly better in that it's using a range rather than just one single date. In terms of how that's calculated, for anyone who isn't aware, the predicted date, that's based on the average daily completion. The optimistic is increasing that average by 10%, and the pessimistic is reducing it by 10%. So if you're wondering how they come to that conclusion, that's what it's based on. So again, if you were to look at our average burn up over the last 3, 5, 7, 9 days, we can start to see significant fluctuations in our average burn up. In some instances, it's very good if we use the last 3 days, but if we use the last 5 days, it's 8. And you can start to see the variation there is probably something that we should be concerned about if we're using it to forecast a date. And again, well, will we meet our predicted optimistic or pessimistic date? And I would say the predicted date is unlikely, optimistic possibly, and the pessimistic maybe. And I'll reveal in a second as to how I can come to that conclusion. But again, if we're using this to communicate to our stakeholders a delivery date, it's probably not the best thing to be doing given the actual likelihood. So how do we know in terms of if it's maybe, possibly, or unrealistic? Well, first thing we need to do is kind of shift our thinking when it comes to delivery. And we need to move away from being kind of deterministic, thinking there's a single outcome, to probabilistic, which is understanding there's a range of outcomes that can occur. And we see probabilistic thinking in a lot of walks of life. I'm a football fan, so one of the things that Opta has is they have a predicted Premier League table based on the remaining fixtures a team has, the amount of points they've accrued, and it could do things like tell them the likelihood of winning the title, getting into the Champions League, getting into Europe, or getting relegated. Now, for me personally, I'm a Newcastle United fan. Apologies for anyone who's a Sunderland fan watching. Maybe there isn't any. But for me, the prospects of getting into Europe are quite slim. Champions League 4.26%, Europa League 7%, and Conference League 0%. Now, this was a forecast on the 26th of Jan, and any football fans who aren't supporters of Arsenal would have revelled in the kind of way that the Arsenal team came apart last night. But back in January, they had a very good chance of winning the title, close to 82%. And when you look at who was in the title race against them, Aston Villa and Man City, they both had less than 10% chance. Now, as of today's forecast, it's changed. Arsenal's chances haven't changed too much, but Manchester City's have significantly increased. And that's because they've accrued more points. It's reforecast and it's given a new range of potential outcomes that could occur. Sadly for me, Newcastle's chances of getting into Europe are even less. And another classic example of where we see forecasting is weather forecasts, where you look at the likelihood of rain or particular weather that might occur. And you use this to inform your decision making around, do you wear a jacket? Do you go out with a brolly? Do you decide I'm not going to bother and just stay at home because it might rain and I've just done my hair? I don't have that challenge. But use this information to kind of inform your decision making when it comes to what's your appetite for risk. So what does this mean for our tools and techniques that we use in things like Jira and Azure DevOps? Well, we need to start looking at these dates and understand, well, what is the likelihood from a probabilistic standpoint of actually meeting those dates? Because if they're using things like averages to forecast when it's going to complete, that's at best the odds of a coin toss. Now, if someone is funding a piece of work or they're coming to you for guidance around delivery dates, if the odds of getting to that date were the odds of tossing a coin, I don't think they will be particularly pleased. So what does it mean in terms of comparing deterministic approaches and probabilistic approaches? Well, deterministic approaches, they assume single inputs, so a number of particular things, story points, items, whatever it may be. divide it by the average rate at which you're getting stuff done, and that gives you an end date. Probabilistic approaches are working in ranges, and it's not so much you have to use a range in terms of the number of items that you have remaining, but certainly using a range in terms of the rate at which you're getting work done. And the key thing is it's using actual data then. So you'd have seen that the average rate in a lot of those visuals, the team actually never had that average rate. They never achieved it. Sometimes it may be way under it, sometimes it may be way over it. So consolidating it all into one single value is just unrealistic and it doesn't reflect reality. Now, you might be looking at this thinking, well, this isn't practical. I can't say it'll take 4 to 30 weeks for stakeholders, and you're absolutely right. So how do we think about this kind of pragmatically? So assume we did have a burn up and it was projecting a single date that we were going to finish based on an average rate of completion. If we're working in ranges, we're doing lots of burn ups. So we're doing this hundreds and thousands of times over, and we're getting a different end date each time for our particular piece of work. And then what happens is we can plot these different outcomes in a histogram. So we can see the range of outcomes that could occur, and we can start to assign a probability to them. So we can start to look at, okay, in terms of the outcome, how long it will take. We can start looking at, well, 50% of the time, how long does it take? Then we can increase this to maybe 70% of the time, how long does it take? Then all the way to 85%. And you can even go as far as 95% if you're very risk averse. But we can start to use this to understand the duration associated with the likelihood or confidence or probability. So that we can use to make informed decision making around when are we going to finish? When is this thing going to be done by? If you haven't read these books, then you absolutely should. So Dan Vicanti's work, classic when it comes to things like flow metrics and forecasting using probability, much better explanation than I've given. So if you haven't read those, please do so. But in terms of tooling that's available, all my stuff is free and open source. So everything I showed today, you would be able to get started with it in your organization right away. So I use a when will it be done chart, and I assign probabilities based on simulating the backlog 10,000 times. So we can say, okay, if we have 141 items to complete, 85% likely to be done on or before the 11th of August. So if a stakeholder comes to you and says, well, I want to be done by the middle of June, you can use this information. So, well, actually, it's less than 50% likely we're going to be done by that date. So if we do go down that route, it's probably a very risky decision and a decision that we don't want to make. So, like all good practitioners and practitioners that are empirical, let's look back at that project that I was working on 11 years ago and let's rerun it through our model. So I was communicating that we were going to go live on the 5th of June. Actually, using this method, it was less than 5% likely we were going to meet that date. And actually, the date that it did go live was around the end of July. So actually, reality was way different than what the expectation was. And I learned this the hard way by having the CIO call me up and say, what the hell's going on with this project? If I'd been aware of these methods, I might have been giving a different answer. Similarly, when we look at ADO, so the example I showed, we had a date of the 13th of August, we were going to get it done by. Now, if you use the last 2, 3, 4 weeks worth of data, there was 0% chance of meeting that date. If we bring 5 weeks data into it, there's 50%. And then if we bring 6 weeks into it, there's 80%. So it starts to become more confident that we'll meet that date, but only through using old data, not new data. So it's not like the team is getting better. Arguably, the team is getting worse and have probably stabilized in terms of what they're getting done. But we're communicating a date that is probably not very realistic in terms of what we're going to achieve. Same with the JIRA date, the likelihood of meeting, I talked about like maybe, possibly, when you actually run the numbers through it. So the predicted date around 43% likely, optimistic 34% likely, and pessimistic. So pessimistic, like probably like your most risk averse, that's only 52% likely. So that's the way that some of these tools are misleading a lot of people out there that may be using them in their day to day. The dates that they're putting out there are not very achievable and realistic in terms of making delivery commitments to you and your stakeholders in your organizations. Now, some of you might be sat there thinking, well, this is no different to averaging. What's the difference? I don't have any data to convince me this works better than averaging. And that would be a fair challenge. So again, like all good practitioners, let's be empirical about it. So one of the things I did when I worked at ASOS, like Helen mentioned at the beginning, is I looked at teams' data and I compared using average methods versus using these probabilistic methods. So for 11 teams, I gathered their average throughput completion rate and did some projections at various different time horizons, 2, 4, 6, 8, 10, and 12 weeks. With this particular team, with these set of teams, I'm using a range of historical data there. So 6, 8, 10, 12 weeks worth of historical data and forecasting, okay, for the next 2 weeks, how many items are the teams going to complete in that time? Then what we can do is we can go back and say, well, these were the actual results. So we can now validate our forecasts with what actually happened versus what we were forecasting. And this is a key thing about these methods. People that advocate for them, the first challenge to them, of course, should be, well, how accurate is your model? Nate Silver in the book The Signal and Noise, very famous forecasting book, he talks about the importance of calibration, how you have to calibrate your results. So weather forecast, they look at, well, did rain occur or not? They don't just say, well, that's what the data told us and that's it. So it's really important if you are using these methods that you're validating your model. So if you look at over 2 weeks, what the team actually got done, we can compare this with what we forecast using our average. And anytime it's in green, great, they achieve that or more. And anytime it's in red, okay, we over forecast. We said they were going to do a certain amount of items and they didn't come near to that. And then what we can do is we can look at this over various different time horizons. So anytime we see red, that's where the forecast was effectively wrong. And this is using the average. Now, what we can do is we can overlay when we used probabilistic methods, in this example, the 85th percentile, and hopefully it should start to paint a clearer picture in terms of the accuracy of these two techniques. When you put them side by side, the average was correct 59% of the time. So there were 176 scenarios, 104 of those it was correct. When we used the 85th percentile, it was correct 81% of the time. Now, if you're in a delivery role, I would think to get a more than 20% increase in the accuracy of data you're forecasting would be a no-brainer. But many times people haven't seen this information. So hopefully that gives you confidence in terms of how effective is it as a technique. Now, others might say, well, this only applies in a stable system, and you can only use this if your throughput is predictable. And the problem with predictability is we need to look at it objectively rather than subjectively. Again, some great resources for you on that. Donald Wheeler's book, Understanding Variation, and Dan Vacanti's most recent book, they will give you far better teachings than I would around understanding things like predictability. But the short story of it is your data, you can put it through what's called a process behavior chart. And you can look at over a period of time, how much variation was there in your information. And you can use what's called a lower natural process line and an upper natural process line. And it will tell you basically the bounds of predictability in your data based on the historical data. So for this particular example, we're looking at a retail shop. We're looking at their daily takings on a daily basis. We're looking at the weeks through to maybe the end of the month. Now you can see there's fluctuation where on Saturday and Sunday, the daily takings are a lot higher. You would expect that being in retail compared to days of the week where it's dropping below. But everything we see here is within routine variation in our process. If we expand it a little bit further, we can see on the last Saturday of the month, we start to see a big spike, and that was way beyond that we would normally expect in terms of our daily takings. Now, it doesn't tell us what the answer is. Could have been more people in town, could have been an event in town, could have been a sale in store that day. We don't know that. But it gives us cause for investigation in terms of, okay, something might have happened here. We need to go and check it out. And what we can do is we can apply this same technique for our throughput and seeing if it goes outside that bound of natural variability. So for this particular team, again, this was a team I worked with at ASOS. The engineering lead for the team, he was telling me that he didn't think his team was very predictable. And I was saying, well, why is that? He's like, well, it's really up and down in terms of the numbers they're completing. But when you actually put it through this technique, we can see that the variation was within what we would expect. If it would have been beyond 20, then it might have been cause for concern. It might have been something to investigate. But whilst it was up and down, it was well within the bounds of what we would expect. So when it comes to forecasting, we can have greater confidence in our forecasts if the numbers stay within these bounds. Now, you don't see a lower line because Throughput, you can't have less than zero throughput. So that naturally becomes the lower line. But if it's above the upper line, then we can still forecast using it, but we might want to tread with caution in terms of the results it's putting out. Now, you might say, well, this is a talk about going beyond burnups. You can still use a burnup from a Monte Carlo perspective. And this was a very cool one I saw on LinkedIn the other day that someone had done, I think using AI, and it's open source, it's free. So if you want to use it, that'll show me you've not listened to anything you've heard today. But there's a link there if you want to go check it out in terms of using a Monte Carlo that's web-based. The problem with Monte Carlo simulations and people that advocate for their use is there is a very big underlying assumption when we use that particular technique of when will it be done. And that is that the team is only working on one thing, or the team works on things in sequence. Any team I've worked with in any organization is not just working on one thing. I'm sure as advocates for limiting work in progress, we would much prefer that, but that just doesn't reflect the reality of organizations and teams that operate in a software development or product development context. So, why does this matter? Well, if you've got a team that is working on a feature, so I use feature, you might call it epic, it's the level above story basically. And when they're only working on one feature, it's great because if they have a week where they complete 4 items, so this feature had 10 items in it, then we know that we can take 4 away from that feature. And then if we have another week where we complete 5 items, then we know we've only got 1 item left because we're only working on one thing. So all our throughput is going towards that particular feature. But what happens when feature whip is 2? And that's where it starts to get more complicated because when feature whip is 2 for just 1 week where they complete 4 items, there's 5 different scenarios that could occur. Now, even a feature whip of 2 would be a massive help for a lot of teams. A lot of teams are working on many features at once. So that number is only going to increase. So when we're looking at techniques for when will it be done, like we showed before, they're completely invalid if this is your scenario because you're not just working on one thing, you're working on multiple things in parallel. So your throughput is going to be distributed across different things. But that doesn't mean that we can't use probabilistic techniques. We just have to think about them differently. So what we can do with a particular team, and this is just some dummy data to give you an example, is we get a list of epics or features that they have assigned to them, and we have them in their priority order based on how they're ranked in our tool of choice, ADO or Jira. And then we look at them in terms of, well, do any of them have any due dates? What's the progress in terms of the completed count and what's remaining for those particular items? Then what we need to do is we need to think, well, how far out into the future do we want to forecast? What confidence level do we want? How many things do we work on in parallel? This is crucial. And also, do we want to have the ability to change our throughput, i.e., we can scale it. So if we think we're going to pay off a load of tech debt and that's going to make us go faster, we can model that. And what we want to do is we want to randomly distribute our throughput based on what our work in progress is. And that you can turn into a visual like this, and you can start to look at for those particular epics or features based on the order they're in, playing around with different confidence levels, how many things we're working on in parallel, and even if we scale or descale our throughput, what will get done by that particular date that we put in. So in this particular example, looking at the next 6 weeks, anything that's in green that completes on or before the forecasted date with an 85% confidence, or you can change it to 95 if you want. Amber or orange is going to miss it by up to a week. Red, it's going to miss it by more than 1 week. So we can start to model the different scenarios that could occur very quickly. As practitioners, we'll advocate for things like stop starting, start finishing. And that's great as a sound bite for people, but for people that are that aren't in the agile bubble, they don't really know what that means. This allows you to make it real for them. If you can show the impact of stopping starting, i.e., having less features or epics in progress and focusing on finishing, so only having a few, we can start to see how more gets done from a delivery perspective. And again, it's important that we understand in terms of how predictable our input data is. So there's an example from a throughput perspective, just showing you from the process behavior chart side of things, how predictable is this data? Is it within our expected values of variation? If so, great. We can use it confidently from a forecasting perspective. If it wasn't, we might want to tread with caution. But again, there is an assumption being made here, and we know what Dwight Schrute thinks about assumptions. So, in a scenario where you have one team and they're working on a bunch of features independently, this works fine because there's no dependencies, they're not working as part of a bigger piece of work. This is an example, again from ASOS, where there were a number of teams that were working on a new customer loyalty program. In this particular instance, the promotions, the bag, and the content team. And this was their feature Monte Carlo chart for each particular team. And we're saying, based on what they're entering, this is the day that these teams are going to finish. So if we simplify it a little bit, we can see each particular team with a certain degree of confidence, how much was remaining on their backlog when they were forecast to complete. So we can say, well, 85% confidence that we're going to complete the whole thing by the 3rd of March, because that's the latest that any of our teams finish. But that's not strictly true because when you think about it, all these things are independent events. But if we were imagining that each of these teams had to roll a six on a dice, you wouldn't say there's a 1 in 6 chance they're going to be done by that particular date. You'd say, well, that first team has to get it, that second team has to get it, and that third team has to get it in order for us to meet that particular date. So what you need to do is you need to multiply these confidence levels, and that would give you your true confidence level of meeting that particular date. So instead of saying 85% confidence, it's actually 61% confidence because we multiply 85% by 85% by 85%. And that means actually we have 61% confidence we're going to complete by the 3rd of March. Very different story from saying 85% done by the 3rd of March. But Dwight Schrute is back again, and he's telling us that we're making assumptions and it's just making an ass out of ourselves and not him. And that is, what about when dependencies happen? So, what happens when the content team becomes dependent on the bag team, and when the bag team becomes dependent on the promotions team? And before you know it, our whole kind of loyalty program MVP has gone to shit. So, what do we need to do in order to address that? Well, a new kind of thing that I've been building based on different challenges my clients are having is a multi-team Monte Carlo simulation. So here you get all your respective teams that are involved in the initiative, project, whatever you want to call it. And we look at, first of all, their throughput data. So we look at their throughput data and we say, well, is the throughput data predictable? And we can put that through our variation and see where there may be some teams where we want to tread with caution with the forecast we're making. The teams where we can confidently forecast, those are ones that where the data's fine, but the ones where it's maybe outside that orange line, we might want to tread with caution with that particular date. Then we want to look at, well, how many items does that team have remaining in terms of their particular epic or feature it is that they're working on? And let's link that to the actual information that's in the backlog, so we know that it can reflect reality. Then let's look at, well, how many things are they working on in parallel? What confidence level do we want? And then also if there are dependencies between those particular teams. And then once we have all that information, we can forecast the date for each given team, and we can get a combined confidence level in terms of when's the date the whole thing will be done by, and what's the confidence level we can attach to that. So in this particular scenario, 95% multiplied each time brings you about a 77% confidence. And that says we're going to finish on the 20th of March this year. But we know that reality is very different and that things change very quickly when it comes to working with agile teams. So what we can do first of all is, well, let's align the remaining items in the backlog with the remaining items that's in the feature count. So then we see the date shifted to the 6th of March. But then Team A might get feedback that actually doubles their remaining scope. And we can see now the date for Team A has changed. It doesn't make our overall piece of work go longer because we haven't identified any dependencies, but we can see very quickly that one piece of feedback has elongated the date for that particular team. Then let's have the scenario where Team B and Team C, they're pressured by leaders in the organization that, oh, you need to pick up another piece of work because there's an urgent commercial commitment to our customers. So that means that their epic and their feature whip has to go up. And then we can see the consequence of that decision and how significant that is. So that moves the date for those two particular teams, but it also moves the date for our overall initiative. So for Team C now, they're working on two things. That means one of those things is going to finish a lot later. And in this instance, we've shifted our date significantly. Now, let's say we've got Team D and Team D have a scenario where someone's leaving their team. and someone new is going to be joining the business and therefore they need to get up to speed. So do you know what? If we're going to be more risk averse, we probably want to take a higher percentage confidence in terms of our forecast. So in this particular scenario, we're going to choose our 99% confidence, and it's going to change our date. It's going to move it a little bit. And it hasn't changed the overall date, but it's actually increased the confidence because now one team's choosing a slightly higher confidence level. So you can say overall our confidence level is higher. And the killer is the dependency. So when Team E then becomes dependent on Team C, Team E can't start till Team C is done. So the duration of their piece of work, thankfully in this scenario, it wasn't too many things that they had, just five. That means that they're not going to finish till the 30th of July, and that means our overall thing isn't going to finish till the 30th of July. But it's very easy to see how quickly these things can impact delivery and where there are dependencies, and crucially, when work in progress increases, more often not due to pressures from outside the team, the negative consequence that can have in terms of the project or initiative that we're working on. So, well, when should you use what technique to forecast? Well, I would say burnups never, unless you like being wrong or taking severe risks. The when will it be done chart or a what will we get chart. So, a single team that's working on one particular epic or feature that doesn't have any dependencies on other teams, then that makes sense to use it. However, if that isn't your context, let's say you've got a single team and they're working on multiple things in parallel, but they still don't have any dependencies on other teams, then you might want to use that feature at Epic Monte Carlo, so the red, amber, green table that I showed. And then if you've got a scenario where you've actually got multiple teams working on an initiative and there may be dependencies between them, that's when your multi-team Monte Carlo is the best to use, because here you can start to forecast the consequence of those things changing, and particularly when dependencies arise, what's that going to mean in terms of our end date? Now, I mentioned about all the stuff being free. It's something that's very close to my heart in terms of if we're to truly further our industry and our practices, we can't put stuff behind a paywall. So if you are interested in getting started with this kind of thing, there's links to it there in terms of what particular tool you might want to use. If you want to use it on your desktop, if you want to use something web-based, if you want to just have confidence in it and playing around with it in the web with dummy data. Again, there's links there for everyone in terms of getting started. And Helen mentioned the book. Shameless plug for it there. If you haven't checked it out, you can do so. If you have read it, thank you for your support. And I did promise Helen that we'd give away a couple free copies to people that came as a thank you for attending. So I don't know how you're going to do that, Helen, if you want to do a wheel of names or whatnot. But it is my thank you to two of you for sticking through this. That you get a free copy of the book sent out to you. And yeah, if you want to connect, you can check me out on LinkedIn. But yeah, I think we can open it up to questions.
Okay, so thank you very much, Nick. Let's give him a round of applause. I need to quickly, now you need to come up with some questions, people, because I've got to work out how to do this wheel in the background. So let's start firing questions at Nick on what do we want to know about what he's just talked about, any challenges, anything whatsoever. There's got to be some so I can do this wheel.
I've got a question.
Thanks, Tomo.
So, you and I have worked on very similar things. It'd be fun to share a screen sometime and compare. But in your multi-user or multi-team Monte Carlo is fascinating. But where my research is different is in modeling. It's one thing to say, here's a whole bunch of data points from the past. Let's do some Monte Carlo on them. And where I looked at that is, I see a trend here. The throughput's leveling off, or the scope is constantly increasing, or whatever. If you model scope and model throughput separately, you get a better idea of where the point is. And the range of those two gives you a real range you can model for your probability.
Yeah, so so effectively like forecasting, doing the same for throughput, but doing it at the scope is kind of what you mean, right?
Both. You got to do both.
Yeah, yeah. Did you use like SensorDAP for that? I used to use SensorDAP for that kind of thing.
I used a couple tools I had in Jira just to do the modeling,
Yeah.
and got much better results. And it also draws great graphs for bringing to leadership and showing do you realize if you keep increasing the scope like this, these lines don't cross? And ding, they get it.
Yeah, yeah, and yeah, I mean those. I think those work well when the underlying assumption is the team's only working on that one thing.
Mhm. That,
But
that
that's where experience tells me, and maybe I've just been unlucky, that a lot of teams I work with, they don't work that way. They're working on multiple features in parallel, and the killer is then it just makes predicting any sort of end date very unrealistic if you're using some of those techniques, or very far out and probably the answer that leaders don't want in terms of if you model it correctly. Now, the advantage is that you can say, well, actually, if you reduce your whip, then we can see the dates improve.
yes.
But yeah, I take your point that modeling scope growth as well can definitely shine a light as to how stakeholders could not be helping the team.
Hmm. And the dependencies I find are very hard to model. In the as a agile coach, right, usually what I try to do is find a way to reduce dependencies to make the problem solvable.
Yeah, yeah, and you know, and like one of the assumptions in my model is that the de dependency means that that team can't start till that team finishes, and that's not always the case. It could actually be, well, they could do three-quarters of the work and then they're dependent, and you can't really model that. Again, I think if you can show the impact of those dependencies, it starts to show to leaders as well. Actually, if we go after this dependency, it might make our delivery date more achievable, or we might get it done sooner rather than just accepting the dependency and managing it. I feel like that's the cop out for a lot of organizations. It's the easy way out, isn't it? Is, well, we just accept the dependency and we manage it. And it's like, well, actually, if we reduce the dependency and we could tell that story using data in terms of we'd get done sooner, then it starts to maybe put a bit more pressure on people that could help that change.
If you're still working on charts, a chart of the cost of dependency would be interesting.
Yes, yeah. The dependency stuff is like I think the next thing to kind of focus on for me from a data perspective. I think if you can start to Troy does some really good stuff on that, Troy McGuinness, in terms of showing the consequence of dependencies. So yeah, maybe that'll be the next thing that I visualize.
Because they always say, oh, we can't reduce dependencies. Only the database team can do the database. And you said, well, if it reduced the schedule by 6 months, would you do it? Like, well, maybe.
Thank you. Thank you for kicking off for the first question, Tomo. I've got my wheel ready for when we do it. But I've got another question in the chat. And this one comes from Sharon. So, where do you start when you're knees deep in delivery?
Good question. I think certainly I would take time to understand your context first and what would be the most appropriate tool to use. Like for me, when I first started looking at this stuff, and it was kind of a reflection of kind of where the industry was at, I just assumed use the Monte Carlo one, the first one, the when will it be done chart, and that would be fine. And I quickly realized that for teams that were working on multiple things, I was still getting it quite wrong. So I think it takes time understanding, well, what's the setup we have here? Is my team only focused on one thing, and therefore that technique may be the best versus, oh, actually, we're working on multiple things, so this technique may be better. I think a lot of the tools, certainly the ones that are kind of free and open source now, they're pretty easy to get started with. Not just mine, because I'll be biased if I say just mine. There's other tools out there like Lighthouse is another great one. You can just install it locally on your machine. It doesn't even like need to get approval from your security team, and you can very quickly start to visualize delivery data that way. But you need to commit the time to it as well. So there's certainly people that I've worked with in delivery roles that have said, yeah, this is great, but then they aren't willing to commit the time to learning it and then putting it into use. So there is a kind of a commitment needed from yourself. If you're that deep in delivery, you need to set some time aside to really kind of understand this stuff and put it into practice. It won't just tell you the answer within 5 minutes. You need to understand it.
Brilliant. And I think we've got from Fernando, it's probably more a statement than a question. So Fernando says, perhaps instead of measuring at team level, I measure at the flow of features that combine work from multiple teams.
Yeah, I mean, if you're looking at flow, things like throughput, cycle time, WIP, certainly looking at levels beyond the team, like the feature or epic level, is something I advocate because that would probably give you a clear indication as to what you could be going after. Certainly, there's teams that I've worked with where they're fast flowing at the story level, but they're being pushed lots of features to work on in parallel, and therefore they can only be somewhat effective. But yeah, if it's multiple teams that are working on a particular thing, then that's where I think the multi-team Monte Carlo would be the most useful for you, because then you can start to look at if we're working on one particular thing and it involves lots of teams, when is that likely to get done, rather than doing individual reports for each team and piecing them together like I was.
Mm, thank you. Greg's asking, any good tips on how to help teams create and maintain healthy data to use?
So, so there's different schools of thoughts with this. So some people would say, oh, expose the data and then the data will be sorted and teams will care about it and make it healthy. I don't necessarily agree with that. I think the first and foremost principle is much like when you share your data, you have to opt into it. So I think teams have to opt into wanting to use data. It has to come from them. You could show it to them to create awareness, but they have to want to use it. Now, in terms of increasing that focus on it, embedding the review of it into your regular sessions with the team, it could be sprint reviews, it could be retros, keeping some sort of regular cadence where you're looking at it is what I would recommend.
Mhm, cool. Tomo's pointing out that Nave is a great tool to work with as well with advanced agile boards. So absolutely, I can recommend that tool as well. James says, where does your passion to continuously push and investigate the details of the team slash dependencies behavior when I'm sure many times in your experience you've had various managers, etc., say, just tell me when this is going to be delivered?
Oh, God, what a question. I think as a good practitioner, you should realize like you're never done. So you're always trying to find like different ways to do stuff more effectively, and you'll come across a context that was probably unique. So I think the different challenges that teams face is what drives me. And in, those managers you come across that are just tell me when it's going to be delivered. I'll be honest, I'm a lot more bullish when it comes to the techniques we're going to use. So if I work with an organization, I don't say, oh, I'd like to use Monte Carlo. It's okay. Well, if you want to know when it's going to be delivered, this is the technique we're going to use for that. It's not a case of you get to say if you want to use like, I don't know, an average burn up, for example, because you're not in the team. We're the ones that are making that decision. So part of it as well is kind of like, okay, well, if that's your approach, we're going to use the whatever method we want to use that aligns with some of these that you've shown, because that's the way we should be forecasting delivery. We're not just going to do a single date like you would like. And if you want a delivery commitment, then we'll go with a 99% confidence if it's that important to you. So yeah, that's kind of, I guess, my answer to that is, constantly learning, trying to find different, better ways to do it, make that accessible to teams. That drives my passion.